In the next few lectures, the learning objectives are to first, align the design values with in-country practices for ramp wall construction. Second, backcheck the ramp wall thickness for adequacy as ramp fill formwork. And third, analyze ramp wall stresses for fill design in order to determine safe construction practices. So we're going to start with calculating the ramp wall self-weight, of which there are two different methods presented. These are also presented in detail in the Ramp Walls and Fill lecture of the Construction Management course, number 301, where Jay does a great job of explaining these two methods from a calculation standpoint. And below, I've pasted two great examples of each method in the field, along with a sketch that shows the difference between the sloped and level methods of constructing ramp walls using a 3-tier abutment as an example. Remember that a 2-tier abutment would only use 30 and 50 centimeter walls, and a 1-tier abutment would only use 30 centimeter walls. So level walls are constructed by moving 1 meter down from the walkway hump and building 30 centimeter walls straight across. So we'd move 1 meter down. Say our ramp looked something like this. We'd move 1 meter down, and then we'd build 30 centimeter across until it hits either the back wall or the ramp cap. Then we would move another meter down and build 50 centimeter walls straight across to wherever it hits. Then the rest would be 70 centimeter wall. 30, 50, 70. And this always ends up using more material and building more 70 centimeter walls than the sloped method. Whereas the slope method moves 1 meter down from the walkway hump and maintains the 1 meter distance from the ramp cap the entire way. So we'd move 1 meter down, but we would maintain that 1 meter distance for each wall. And we'd have our 30, 50, and 70. Now, if you remember, the basic suspended bridge design course, number 201, also teaches you to assume the entire ramp wall area is 30 centimeters thick. So this being our ramp wall area labeled in white here, the basic course teaches you to just assume this is all 30 centimeters for simplicity. And looking at a section, you can see that a ton of capacity is being lost by assuming this is all 30 centimeters for 2 or 3 tier abutments. And it's important to also note that there are always two options, but you will want to assume that the masonry technique on site will be the level method. So please do all of your calculations assuming this method. Another thing to remember is that Bolivia sites only will follow a different configuration for the 3-tier abutments and 3-tier abutments only. They will use a configuration of 40, 60, 40, 60, and 70 centimeter thick walls to accommodate for masonry technique and the rock availability on site. And you can see in section here for this level method calculation that I drew out, we are getting a lot more capacity from ramp wall weight when we're considering the 30, 50, and 70 centimeter sections.